At 7:32, so I think we'll start the meeting. And this is a members' night meeting, so we have Lori Walton, Alan Dyer, Mark Zalcik, and Orla Aaquist who will be speaking tonight. So we'll get started right away because we don't want to miss those great presentations that are going to be coming up. Okay, April 2026 meeting minutes are on the website in the members area. Has anyone, I'm going to take this off of here. Anyone got any errors or omissions? Anything to add, delete? No? Okay, can I get a motion to accept the minute that's posted on the website? Jeff Whiten, do we have a seconder? Oh, where? Oh, there's Marion Hobbs. She seconded it. Thank you. Okay, all in favor, say aye. Opposed? None. Okay, that carries. Okay, next is the treasurer's report from Jeff Whiten, who's back from his globe-trotting days.
Thank you, sir. So it was a really quiet month from a treasurer perspective. Let me just run through the numbers. So our general account's still super healthy. So we started the month at $80,714. We ended the month up $81,057. All of the revenues that came into our account, though, this past month were from membership dues, and there were zero expenses for the month of April. The casino account, on the other hand, started out the month at $54,210, ended the month at $50,000 and change. Expenses, so there was some BNLO catch up. So many of you are aware. So during the winter, we do snow clearing, we do a bunch of different things. And so there was some catch up expenses for BNLO that came through this month for about $1,600. And we had to re-up for our post office box and our storage locker. So we've got the PO box for another year. And our storage locker, I was able to get that renewed for another 6 months at the rate that we had negotiated a year ago. I guess the other thing that I'll maybe bring up, the last time that I stood up here, we talked to the membership about the new expenditure proposal process. Do you remember? Well, some of you might remember. Anyway, so we did this new thing with expenditure proposals, and the big change to expenditure proposals was that we were going to collect them twice a year. So we were going to do a spring intake for expenditure proposals, and then we were going to do a fall intake. Well, the spring intake happened at the April council meeting. So council did review a couple of expenditure proposals and indeed approved one. So we are going to proceed to buy a Pi Finder just to use it in the observer program, I think, originally. So we'll see how it works. And if it does what we think it's going to do, we may end up buying a couple more for the club for other reasons. So Pi Finder is a go-to device. It's basically a plate solver. So it's a little device that's built on a Raspberry Pi with a camera and onboard software, and you can put it on your telescope, on a telescope that doesn't have a go-to mount, and you can use it as a go-to device. And apparently it works quite well. Alan was talking about it at dinner. Yeah, it's kind of a cool little device. Any questions? Great.
So that would help me find some key lime pie. Okay, so we will get to our guest speakers now. Our first speaker will be Lori Walton giving us a SETI update, then Alan Dyer, then Mark, and then Orla. So Lori, if you're ready to go.
Okay, so I'd really like to thank everybody here at the Edmonton Centre of the RASC for your continued interest in SETI. I think most of you are familiar with SETI, but for those of you who are not, I have a brief introduction. SETI stands for the scientific, and I stress the word scientific, search for extraterrestrial intelligent life. And there's the common joke that obviously there's no intelligent life on Earth, so we have to look elsewhere in the cosmos. What do SETI scientists look for? They basically look for what we call technosignatures, and that is the manifestation of any non-human technology, past or present. This can take the form of radio signals that are engineered and obviously artificial. It can take the form of pollution in the atmospheres of exoplanets. The thinking here is that we've polluted our own atmosphere, so maybe others have done the same. And we're looking for large structures, conceptual structures like Dyson spheres. Humanity has generated its own technosignatures. We have our beautiful city of Edmonton, down in the lower right, taken by Chris Hadfield from the International Space Station. Humanity has sent probes all through the solar system and beyond. On Mars, we have drill holes. We have sample tubes lying around on surface waiting to be picked up. And we even have a helicopter on Mars. And also, we have sent out our own electromagnetic radiation for over 100 years. And that would be in the form of radio waves, TV broadcasts, etc. The modern era of SETI really began in 1960. A young radio astronomer, Frank Drake, somehow convinced his bosses at Green Bank Observatory to let him turn the telescope to look at two nearby stars for any signs of radio transmissions. Shortly afterwards, the famous Drake equation was developed, and this equation really quantifies all the parameters that go into a SETI search. So since then, a number of really important developments. First, in the late 1970s, we became aware that life is far more resilient than we ever thought possible and can live and thrive in extreme environments. Look at these black smoker vents on the bottom of the ocean, spewing out metals, copper, lead, zinc. 500 million years from now, this will be a mineable ore body. But in any case, there's no oxygen, no sunlight, but there's a thriving community of tube worms, spiders, and all sorts of life where life should not exist. Life can also be irradiated, heated, frozen, and it still thrives. And life can be eliminated. We have Jupiter getting pummeled by comets and meteors, and we have in 2013 one snuck by the sun and impacted in Chelyabinsk. And then lastly, the discovery of exoplanets in the 1990s got everyone excited about looking for a second Earth in the habitable zone, hopefully around a G-type star. And I think at this point, about 6,000 exoplanets have been discovered. Funding is very important. It never really existed until 2015 for SETI searches. Breakthrough Listen has contributed $100 million, mainly towards direct radio telescope time for 10 years. It was recently renewed for another 10 years for another $100 million. A couple of years ago, the SETI Institute received a request from the estate of Franklin Antonio in Silicon Valley. He ran a company, but also liked to go out to the SETI Institute's Allen Telescope Array in Northern California. So that funding has had a huge impact on SETI. I think most of you know SETI is my hobby. I have volunteered on the SETI committee of the International Academy of Astronautics since 2004. This particular committee has an extremely broad mandate to look at everything to do with SETI, how stars form, solar systems, formation of life, origin of life, evolution, intelligence. And the committee looks at post-detection issues as well. Okay, so every year the committee meets and has technical sessions at these big congresses held around the world every fall. This past year it was in Sydney, Australia. SETI is just a very small part of these. Some of you have probably attended these conferences or similar large conferences. And I'm happy to say that I wasn't the only Edmonton RASC member attending this. Ian Doctor from Jasper Place High also attended. We weren't able to meet up because of the scope and size of the Congress, but Edmonton was well represented. Okay, I was really happy because our SETI committee meeting was very well attended. It set a record, over 30 people, including representatives from China, so that was new. The good thing about all the funding is there are many graduate students and postdocs now in the field. Okay, so what's new in SETI? The SETI committee worked on, probably looks pretty boring, these two documents. These were first filed and developed in 1989 and introduced to the United Nations and adopted in 2000. They're two documents that deal with how to conduct the search for intelligent life in the universe, and then the post-detection protocols talk about what happens after a detection, who does what, etc. The committee worked for 3 years on this, agonizing over every word to update these documents because times have changed. There's now social media and everything else. One thing I really like about SETI is the multidisciplinary aspect of it. The 4 co-authors on the paper, there's a radio astronomer, anthropologist, a space lawyer, and an educator. Okay, I mentioned Breakthrough Listen is funded for another 10 years. It moved headquarters from Berkeley over to Oxford, England, and this is their new 10-year mandate. What I found out at the conference, it isn't so much new SETI searches now, it's how all the data collected during the search is processed. There's vast amounts of data coming in, and Breakthrough Listen has partnered with some computer chip manufacturers to help facilitate the increase in processing speed and precision. And this has led to real-time data processing for SETI searches. Last year, I showed some slides about ongoing SETI searches. This one is ongoing. The LOFAR search, low frequency radio array, different sites in Europe. And Breakthrough Listen has purchased thousands of hours of dedicated observing time at the Parkes Radio Telescope in Australia and Green Bank, among others. And one important aspect of SETI is something we call piggyback SETI, and that's where you have a little black box that's developed and then stuck onto the particular radio telescope array. At the Meerkat array in South Africa, you have the Breakthrough Listen user-supplied equipment piece of little instrument put on, and there's one at the VLA in New Mexico called Cosmic. And this enables researchers to gather data for SETI analysis without impacting the research of radio astronomers using the facilities. Ongoing searches include infrared, looking for infrared anomalies, and also laser optical searches. And I was happy to see a facility in Italy. The Italians are really supportive of SETI. We have the Northern Cross Radio Telescope in Italy at Medicina, which I visited, I think it was in 2013 or so, and the telescope in Sardinia. They've partnered up with Breakthrough Listen and are conducting SETI searches. And data mining is very, very, very big. Everybody's looking at data collected from current and historical searches and testing out various algorithms, machine learning, whatever it is you would like to do. The Swedes have started a new project described here, looking for infrared anomalies, that would be Dyson spheres, from various catalogs. The SETI Institute has established a Discovery and Futures Lab, and this is to look at post-detection issues. And one thing I like, the SETI Institute is also sponsoring teachers and students to come to the Allen Telescope Array and learn how to analyze real-time and archive data. And you may remember Seth Shostak, who came up to the Edmonton Centre a number of years ago to talk about SETI. He just had an asteroid named after him. Does anybody know this project, SkyMapper? Okay, well, I guess the SETI Institute has partnered with this project. You go to Shopify and buy this thing called a Skybridge device and hook it up to your laptop and telescope. And it's kind of a networked astronomy network. So this would be good for looking at exoplanets and also optical laser beam SETI. SETI Institute is looking at what we call the plasma problem through a program called Strike. Basically, it's looking at how you analyze signals coming from different planetary systems at the source compared to what arrives at Earth. And they're redesigning SETI searches to better match what arrives at Earth other than what is transmitted and may not be representative because of plasma turbulence. I can't explain it further than that. One thing I found really interesting in late 2025 and 2026, NASA went back and sampled not one, but two of its clean rooms used to assemble probes that went to Mars. And much to their shock, they found very, very resistant, not only bacteria, but also some fungal stuff as well. These are extremely resistant. They think they can live in a vacuum. You can irradiate them. Basically, they go dormant. So the implication for this is in humanity's planetary protection protocols, we may have already contaminated the surface of Mars despite our best efforts. So they're taking a look at these microbes to try to determine if that has happened. And another thing I found really interesting is we're not looking just for Earth 2.0 around a G-type star. The SETI searchers are expanding their search. They're including M-dwarf stars and really expanding the SETI search parameters. We know that life can thrive under more extreme environments, so they're taking that into account. And everybody's favorite project, SETI at Home, ran in the late 1990s and concluded in 2020. This is one of the saddest photos I've ever seen. These are Sun Enterprise servers that held the SETI at Home database, including the material that would go out on the web to your personal computers. These were I guess unplugged, and in the hallway at Berkeley, they couldn't find a single museum to take them. So last I heard, they were headed for the scrap heap. But SETI at Home is still active. 14 billion candidate, I don't know if you call them signals, were identified. That's been reduced down to 100, and only the largest radio telescopes on the planet have the ability to go in and target these areas to take a look at these top 100 targets. Arecibo radio telescope collapsed, but Breakthrough Listen has a partnership with Chinese astronomers, and right now at the FAST radio telescope in China, which is the world's largest at 1,000 meters, these 100 target areas are being analyzed and looked at. So SETI at home is not finished yet. Okay, so that's the SETI update. After I attended the conference in Sydney, I went to the Outback to look at some mining areas. It's another, I guess, hobby of mine. And believe me, this relates to astronomy in just a minute. In this area of Australia, you can actually mine sapphires. You can pick them up off the ground. It's crazy. And I stayed at a motel in Rubyvale, this town in the Outback. And their motto is gems by day, jewels by night. And you can literally prospect for sapphires in the day. And they have an honest to God observatory at this motel. There it is. There's a 14-inch Meade telescope. And naturally, the nights I was there, it was completely cloudy. So the people who run this thing were not able to show anything at all. So I was very disappointed. I know a lot of you have been to Australia, and I really envy your ability to be able to get a good view of the night sky. So back to SETI and to wind up, have we found anything? The answer is no. As Carl Sagan said, there's been a lot of scruff out there and this and that, but nothing conclusive. And as Jill Tarter says, if you think of the SETI search space as having the volume of the world's oceans, then we've only actually looked at the volume of water in a swimming pool. So there's a lot more to look at. Thank you very much.
Anybody have any questions for Lori?
So you talked about data and data mining and just the vast amounts of data that the SETI project has accumulated. Was there any talk at the Congress about, emerging AI techniques and maybe the use of machine learning to help sift through some of the huge data looking for patterns?
Yeah, I'd say they're on the cutting edge of that. They're trying everything. So they use a lot of AI, machine learning, the real-time data processing. They're going back and looking at everything now. And I'd say what they're doing is probably state of the art.
Cool.
Not that I'm an expert.
Anybody else? Anybody online? Doesn't sound like. Okay. Thank you, Lori. Next up will be Alan Dyer, talking about some odd aurora forms.
Just online? All right. Thank you. Thank you for the invitation. Well, no, I invited myself.
He did it.
I asked Clayton if I could have a time tonight. This is a follow-up to the talk I gave at the Northern Prairie Star Party, and I know you were all there. Well, about aurora. This is about some of the odd auroras that have been in our sky in the last 4 months or so. And so particularly odd, with the idea that this is something you should and could look for and take photographs of and contribute some science to. So Frank, if we can go to now, is the right button to advance here, is it? Yeah. And all right, there we are. And again, we can get rid of all the lights. You don't need to see me at this point. So odd auroras of late is what I'm going to show you. Some slides taken from my backyard. And we'll go to a couple of points, some all sky panoramas for the projection in the dome here as well. So let's see. And these are all what we call subauroral phenomena. And what that means is auroras that appear south in our hemisphere, south of the main aurora, which we often see to the north from here in Alberta, or maybe overhead at times, but often, as we see in this picture here, over to the north at the top. But sometimes to the south of that, which may be overhead or in the southern sky, you see some other odd forms that are sometimes quite short-lived. And they are very weird. And they take on a whole alphabet soup of acronyms as to what they are. And I observed about 3 or 4 or 5 of different ones in the last few months. So they're often directly overhead from central and southern Alberta. We are in a prime position to see these subauroral phenomena, unlike, say, Yellowknife or places further north where you would typically go to see great auroras. In this case, we see really weird ones from where we are here. And the first one I'm going to show you here is February 15th. We're going kind of in chronological order. Is called, maybe it is an example of what's called a ragda. This is a fairly recently named, the name proposed and picked up around the world and proposed by the group very active aurora watchers in Finland. And then one of their leaders, Emma Bruce, suggested this. It's something of a type of form that we do see from time to time. And what that means is red arc with green diffuse aurora. So it's just a descriptive phrase. That's kind of what it looks like. And here is an example. There's the main aurora to the north at the top of the slide here. And then overhead, and we'll go to the all sky in just a sec, is this weird form of kind of green diffuse aurora in maybe a bit of a red arc. But there's also a thing kind of related called an IPA. That's not a beer. That is an isolated proton aurora. And you know that auroras are mostly caused by electrons raining down along magnetic field lines. That's what's causing the aurora at the top, the normal aurora. But this other green blobs may be protons caused by protons, and it's a little different formation phenomena, and it always produces a very diffuse. It's exciting hydrogen atoms to emitting hydrogen beta light, which the deep sky observers may be familiar with hydrogen beta filters, kind of a blue-green line that some nebulas emit. That's what proton auroras generally emit at, rather than the oxygen green or red. And they're always quite diffuse as well. Frank, if we go to the all-sky slide at this point, there's an all-sky version of that, just to put it in perspective. Because that night I took several images, and there we are. So welcome to my backyard. Here we are near Gleason, Alberta. And over to the north, you see the Big Dipper over here. Do I have a laser pointer on this? Top button. Oh, yes, here we are. So here's the Big Dipper here, and here's Polaris. So we're looking north. So here's the normal aurora over here. And this was February. Here's Orion, prime winter sky here. No snow at that time. We got most of the snow 2 weeks ago. But look at this. We have this green blob across the sky, and it's a little washed out here, but there was a bit of a faint red component. So what is that? And so maybe it's a formation called a ragda, but it's almost probably some sort of proton aurora. You could see the green with the eye, as a gray shape. You couldn't see the color, but the cameras pick it up. So if you see something like that, take pictures, and it will reveal itself perhaps as being a green aurora, but it may not necessarily be an electron aurora. Okay, we can go back to the slides, Frank, and we'll carry on from there, or leave that one up, doesn't matter, and go back to the slides, and I'll continue on through the years. So there was a ragda formation. All right, let's go on to the next slide. Get my button here. And yeah, as I said, there's a normal aurora to the north, but to the south, this strange formation, which just slowly changed. And so what's going on there? And I'll show you a few other weird ones as well. And it's... There we go. Now, this is by far an undisputed classic ragda. red aurora, a red arc with green diffused aurora, because there is very definitely a red arc there. And as soon as scientists saw that, they said, wow, that's really, because that red arc has vertical structures in it, which is odd. And then the green diffuse proton auroras. And so that was back October 2021. That's a very classic RAGDA. In fact, that ended up on the cover of the Journal of Geophysical Research as this was used in a paper by Yoshi Nishimura and et al. And look, there's my name on a paper right there. Look at that. I just contributed some of the pictures, which they use as the data. And so this is unusual. I can't tell you exactly what's going on with these things, but it's our data that can help scientists determine what's going on with these things. Now, what you may have heard of is something somewhat similar, but are they related? Are they similar in cause? I'm not sure. It's called a SAR arc. And that's stable auroral red arc. So this was a month later now, March 20th. Once again, a fairly normal aurora to the north, but just to the south there, you can just kind of barely see it at the bottom of the picture, is a faint red arc. And these have been known about for some time. And since 1956, even before satellites, the like. So the normal auroras are caused by electrons streaming down magnetic field lines from out in the magnetic tail vertically. But these SAR arcs are caused by currents flowing horizontally. East, west, west, east. I'm not sure what the flow is. May depend on the time of the night. But they're hot thermal currents flowing horizontally, we have this kind of ring system of currents around the Earth, which can get very active and heat up and cause these red SAR arcs. But these are subvisual. You generally do not see these at all with your eye. The deep red is very hard for the eye to pick up, and they're quite faint. But I just took a picture of this thinking there might be a SAR arc, and there it was. And Frank, I think there's an all-sky of this as well. So we can just put that in perspective with the all-sky image with the planetarium system. And those watching online, you're not going to see the all-sky images on the planetarium, but it's the same image that we're just showing on the PowerPoint here as well. We're just going to go to the all-sky view of it here, if we can do that. And just to show you that it's something that's going all the way across the sky. Where are we? Oh, over there. Oh, Frank, well, just when I need Frank. All right, doesn't matter. Okay. Whoops, sorry. I need to go back. Here is a horizontal panorama of it here, and stretching more or less 180 degrees. So once again, the normal aurora to the north there, and then this SAR arc. You can just find the button here. This SAR arc just slowly going, arcing across the sky here. And they can be quite long-lasting as well. They don't do anything. They don't dance. They're just a uniform red arc across the sky. And to say, sometimes you may not see any evidence of it to the eye as well. I saw a very bright one down from southern Arizona in October 2024 when we had a fantastic all continent-wide aurora to show. And I was down in southern Arizona, and I saw a bit of a red glow of aurora to the north, but there was a brilliant red SAR arc across the sky that was all the way across the continent. They're very widely seen. So those are SAR arcs. Now here, a month later, in fact, just a month ago, morning of April 10th, a weird green arc appeared across the sky. And to the eye, you could see this. I was doing an all-night deep sky shooting session, stepped outside about 3 a.m. to check on how the camera was doing, and I see this gray arc all the way across the sky. There had been aurora through the night, but nothing very much to speak of, nothing to spoil my deep sky photography, just a normal, no big substorms, no big displays. But step outside about 3, and there's this gray arc across the sky. I thought, oh, clouds have moved in. or it's an aircraft contrail or something. Took the camera out. No, it's green. It's aurora. What this was first, when I posted this on the Alberta Aurora Chasers Facebook page, the suggestion came back from some experts that this could be an example. There's another acronym called a SAMPS, Subauroral Morning Proton Spots. So once again, a form of proton aurora, and it appeared as a broad arc across the sky and then gradually kind of retreated over to the southeast and kind of disappeared to the southeast. It wasn't doing anything too much other than just changing in brightness. And so this could be another form of proton aurora, fairly short-lived. But as I say, there was a normal weak aurora to the north all night long, but with no major outbreak or substorm, which is not what a SAMPS is. A SAMPS proton aurora generally does appear after there's been a big substorm, and then it dies down again. That didn't happen this night, so it didn't really have the characteristics of this subauroral morning proton spots, but it was detected from space, from one of the NOAA weather satellites that looked down. There's the normal aurora to the north there, up here to the north, and there's where I am, east of Calgary, and here's Edmonton, here's Fort McMurray, and here's that arc. So it was captured at that time there. And so it's a very odd phenomena. And then an hour later, another satellite captured it again, and look, it had moved to the east. There, now it's over North Dakota here. And so just this afternoon, and let's see, do I have another slide of it? Yes, here it is, just kind of retreating. Just this afternoon, I got a note from some scientists who are very interested in this. They picked up on this as soon as I published this, a month ago on the Alberta Aurora Chasers Facebook page. He said, that's really interesting. So I'll be messaging them back and forth. And just this afternoon, just earlier this evening, got a note from Tanya to say, we have some more data on this. We're looking more satellite data, and they think this is not a proton aurora. This could be an electron aurora, like a normal aurora, but behaving a little differently and from a different source that I don't understand yet exactly what this is an example of. But this is something yet again unusual, worthy of yet another acronym for someone to devise. And so I may be submitting these images for a poster paper or a talk at a space weather conference coming up. I won't be giving it, but contributing the data to a talk at a space weather conference coming up next month in Goddard Space Flight Center in Maryland. So this is the kind of thing that we can do as amateur scientists. Now, a week after that, is what is almost certainly some sort of proton aurora. There is a fairly prominent aurora to the north. See, we gotten some snow here, April 17th. And then some blobs of greenish cyan green appeared to the east and then expanded to cover the whole sky, a wide diffuse arc to extend across the sky. And those are almost some sort of proton aurora, I'm guessing, from the color and the like. And this may be a true proton arc. And if those of you who remember the early days of Steve, who's coming up next, that we were calling that a proton arc. And until we were told, no, that's not the correct term. Those are not proton arcs. And don't call it that because you don't know what it is. But this may indeed be an arc of proton auroras. And once again, normal aurora to the north. No, this is the next night. Sorry. This is now the next night, April 18th into the morning of the 19th, just after midnight. A normal aurora to the north, a KP5 substorm this night, which retreated north and subsided. So when you get KP5, bright aurora, and then it dies down a little bit, quietens down, those are the prime conditions for Steve to appear. This is the famous subauroral phenomena. This is the poster child for subauroral phenomena, who we in Alberta have made Steve famous. The Alberta Aurora Chasers Facebook group really put Steve on the map. And the scientists who then saw our pictures and say, what's going on with that? No one had quite seen anything quite like this before. we had been seeing these things for many, many years and calling them mistakenly like a proton arc or whatever. But this is something more like a SAR arc. It's a horizontally flowing hot thermal currents. And that's what the name means, strong thermal emission, velocity enhancement. The name was, Steve was come up first, and then someone back acronymed it to Steve. And here it is. There's a normal aurora to the north, I just showed you, and then Steve appears, and this is about after midnight into 1 a.m., and just as the normal aurora died down. And classic Steve, a mauve or pink arc, green picket fence fingers below, vertically oriented, and looks like white rays of material joining the two. And that's a very classic Steve. I saw it low in the south. You can see there's Leo there in the picture, and it's below Leo. But friends of mine who were in Waterton Lakes that night saw it straight overhead from them. So from here in Edmonton, it would have been visible, but maybe very low in the south from Edmonton. So that's a classic Steve, which has been studied a fair amount. And here is a time lapse. He didn't last very long, half an hour, which is typical for Steve. And it was barely visible to the eye. This was not a bright Steve. But I got the camera and the time lapse camera going, and there's some normal aurora at the top pulsing. And you can just barely see it. He's fading out, and you can see the green picket fence fingers. I'm repeating it over and over here. Are visible, and it's dancing a little bit from east to west, left to right. Here, we're looking south. And so that is classic Steve flowing east to west. And so these are all subauroral phenomena which are being studied and which no one, in many cases, really fully understands exactly what's going on with these things and where these things originate from. But by taking pictures, close-up pictures, time lapses, whatever, we can contribute. And putting them on in fact, that's what's coming up next year. Oh, here. If you go to the Alberta Aurora Facebook page, Chase's Facebook page, and go under guides, and then you'll see Aurora Chasing handbooks. And the one that I recommend is the Field Guide for Citizen Science. It is a menagerie of all these weird forms in print form as a PDF you can download. There's the IPAs, the isolated proton auroras, fragments, which are of great interest. I can't say as I've ever seen that. These are not my pictures. These are from contributors to the Field Guide. And weird or fragments. And then continuum auroras. This is something that the group at the University of Calgary are studying. White beams. Continuum, they're emitting a whole broad spectrum of colors, not just green or red. What's going on with there? That's an active area. And as these get mistaken for Steves, but they're different. And then you can get mixtures of all kinds of auroras. There's examples of all kinds of them going on there. So download the Field Guide. It's a great guide to these auroral forms. And as soon as an odd one is identified, it's given an acronym, but we don't still understand what it is. And we're on the downslope now. Past solar max last year and the year before. We're on the downslope now, but we can still get great auroras at any time. And they can then trigger some of these weird subauroral phenomena. And so keep looking up. And the great thing is that even though it doesn't get fully dark here in the summer, it gets dark enough for us to see the northern lights all summer long here. And I've seen great displays right around solstice. Oh, here we are. Here's the final image that we missed there. So here is their normal aurora to the north, and then the SAR arc, but it's fairly faint here going across the sky. So the lesson is, don't just look north. Look south as well and take pictures. There may be some stuff, weird phenomena lurking in the north or in the south that only your camera will pick up. And if you do see something, take lots of pictures, take a series to see how it evolves. The holy grail is to see a SAR arc evolving into a Steve. It's been done once by Ian Griffin in New Zealand, because they may be related, but we haven't caught it in action except for one time. And that's something we can do with our cameras better than the fancy cameras that the scientists might have deployed across Western Canada. Really, in many ways, better, with higher resolution than they might have. So we can really contribute some real science. And I think that was my theme last September in my talk as well. All right, that's it for the presentation from me. Thank you.
Thanks, Alan. Any questions for Alan before he goes and sits down?
Yes.
Good. Okay, hang on, I'll bring you the mic.
Thank you. I have on my phone a video of a aurora that I took, and it looked like I didn't see any examples of it on your slideshow. But to me, I don't know anything about them other than I think it's a normal aurora. But I'd like for you to have a look at it afterwards and tell me what it is. But it looked like a green, like a water spout. And it was twisting and rolling, and it had ridges in it, and it was very, very bright. But I'm wondering if I missed the boat on that, because after that was gone, I stopped filming. But maybe if I had it kept on, I might have seen something else.
You never know. Again, depends on where things are in the sky. But you never know. Some very broad activity, energetic activity, can trigger something else somewhere. It dumps a lot of energy into the atmosphere, into the magnetic field, and that manifests itself as one of these sub-aurora phenomena. So yeah, just because the big show might be over, don't go home. That's when Steve appears.
That's what I was wondering.
Yeah, that's when Steve appears, and that's when a lot of these other weird phenomena appear. The energy gets dumped into the atmosphere by a big auroral substorm, and that energy gets manifested in some of these subaurora phenomena later, just maybe only a few minutes later, but in the next hour or something like that. And then capturing that evolving and how that changes can be quite useful to science. Even though there are, that's something else I wanted to mention, is that any of you have observatories or whatever, you got all sky cameras running. I understand there's one out at BNLO. Make sure you archive that data. Don't erase it the next day, because you never know when a week later you realize there was something really interesting happening that night. You might have a whole all sky record of it from dusk to dawn. That would be very useful to science. And so if you've got an all sky camera, make sure you're archiving that data enough that you can get at it, and it doesn't get erased before people realize there was something valuable happening that night to be aware of.
All right, thank you. I'll be more diligent when I'm recording. I won't shut it off as soon as it disappears. But I'll track you down afterwards and let you have a look at it.
Yeah, sure. Yeah.
Right,
Time lapses are good, and if it's a very bright aurora, our today's cameras can do real time movies, and that's very useful. I've had a paper published using my 4K movie of Steve, where it was showing structures. I think I showed this last September, showing structures in Steve that you were not seeing, and the time, a 2-second, 3-second exposure that we normally use would blur. But a real-time movie at 30 frames a second is showing this fine motion that no one has seen before as well. We can get those kind of pictures and data. But, getting on the Alberta Aurora Chasers Facebook page is a really good spot to find out what's going on and to publish. Put your stuff there and put it out of interest. And someone will pick it up and say, yeah, I want to learn more about that. All right. Thank you.
Thanks, Alan. Okay. Next up, we got Mark Zalcik talking about beaverhead shatter cones. I haven't a clue what he's talking about.
Perfect. Good evening. Who is this character who's staring off at the distant Beaverhead Mountains of southwest Montana? Kind of looks like Peter Garrett, the lead singer for Midnight Oil. The guy who invented such lyrics as "Let's give it back." But no, it's not Peter Garrett. In fact, it is Charles O'Dale, the self-described crater explorer of Canada, who goes around to different impact craters in Canada and the U.S., explores them on the ground and with his aircraft called Go Zoom. So more on Peter and Beaverhead a bit later. Most of us are content with just observing the major meteor showers every year, but some of us want to delve further into it and actually go out and look for the meteorites that have fallen on Earth. This is an example of the Whitecourt meteorite northwest of the city. But meteorites can be kind of hard to find. Some of them fell a long time ago. You're looking in areas where you might have to search for several days just to find one. The annals of history have examples of great efforts to try to find meteorites, and nothing's been found. This is a local example. In 1954, a fireball fell, and they thought it fell in Wabamun Lake. And a bunch of RASC people and U of A scientists got together with the project WHAM, Wabamun Hunt for Aqua Meteorite, which included divers actually going into the lake and trying to scour the bottom to find this meteorite. This, I believe, is Julian Kiniski, who went on to be a weatherman for CFRN and an Edmonton alderman. So unfortunately, nothing was found with that effort. Wouldn't it be nice to find something meteorite related that was so plentiful that you could just walk around anywhere and just pick them up so easily off the ground? There is an example, shatter cones. Now, shatter cones are rocks embedded with striations caused by the intense pressures during an asteroid impact, like shock waves instantaneously coursing through the rock. Shatter cones have a conical shape with the apex pointing to the center of the impact crater. They tend to be found near the center of the crater. As many large craters or impact structures have shatter cones, and many of these craters are in Canada's Canadian Shield. For example, Deep Bay, which is part of Reindeer Lake in Saskatchewan. You got West Hawk Lake in Manitoba, in Whiteshell Provincial Park. Ontario, of course, you got Sudbury, that's a famous one. And Quebec, you've got Manicouagan and Clearwater Lakes. So there's quite a few examples. So once you've found an outcrop where these shatter cones exist, you will see them lying all over the place. And it's just a matter of going around and picking them up. Quite easy, actually. Shatter cones can be microscopic in size, all the way up to 10 meters. Here's Charles O'Dale again with the largest shatter cone known right now, and it's at the Slate Islands impact structure in Lake Superior. This entire cliff supposedly is one huge shatter cone, 10 meters tall. Now, going back to Beaverhead in southwestern Montana, Beaverhead is thought to be about 600 million years old, so it formed in the Devonian even before North America was a continent. So that's kind of showing where it was when the impact occurred. The crater is thought to be about 100 kilometers in diameter. But the problem is subsequent tectonic activity. That would be the original location of the crater. The subsequent tectonic activity has moved everything off kind of towards the border with Montana. And instead of a nice round crater like you would normally see, all of the shatter cones are just jumbled up and caught up in cliffs and outcrops and that sort of thing. So that shows the location right now where the shatter cones could be found. So it's in the far southwest corner of Montana. Now, I took a trip down in 2014 to look for the shatter cones. Accompanying me was my son Justin, and actually pretty close by is Yellowstone National Park. So that's kind of a nice side trip. If you're going to go look for these shatter cones, is go stop by at Yellowstone as well. And of course, Yellowstone is famous for its geothermal features, the most prominent being, of course, the Old Faithful geyser, which shoots a column of vapor up in the air about once an hour. So that's the most famous one. There are lesser known ones. For example, the Human Head Hot Springs. Look closely into the rising vapors and see the image of a small child. Waterfalls, all kinds of waterfalls in Yellowstone as well. The most famous is the Lower Yellowstone Falls, 100 meters in length. And at the brink, there is actually a little viewing area, as you can see off to the right, where you're looking right over the falls. Spectacular. So 100 meters. And then there's lesser known ones, Gibbon Falls, which is only about 25 meters. So quite a bit smaller. Here's a question. Does anyone recall doing something absolutely stupid that endangered your life? Any hands? Yeah, I see at least one. I thought I'd dig up the next picture because it happened almost exactly 50 years ago at Gibbon Falls. My brother Dave took a family friend of ours, Roger, and I for a whirlwind trip through Yellowstone. And this is one of the places we stopped at. And I took a little saunter towards the brink of the falls and noticed a big tree trunk sprawled across the width of the falls. So this is what resulted. That's looking over Gibbon Falls, August of 1976, so almost 50 years ago. Please do not try this at home or anywhere for that matter. Totally ridiculous thing. Had I gone over, it would have been an afterthought half a century. So no stupid talks about weird rocks or anything. Yikes. This is a satellite view showing the area right around where the shadow cones can be found now. There's not much forested area. A lot of it's right above the tree line, actually. To get there, take the interstate that goes south through Dillon and continue until you see this reservoir on the west side of the road. At that point, there is a road that goes directly to the west. So you follow that until you get to this T intersection with Medicine Lodge Road. So if you take this road all along its full length, this is where you're going to find the outcrops and the cliffs where you can just stop by right next to the road and saunter off into an outcrop and look for shadow cones. Here's Justin walking down a scree slope, gleefully picking up shadow cones. He's got one in his hand right there. Now, the picture you saw earlier on, actually, the shadow cone had a conical shape. But something that I've noticed is in a lot of the specimens you pick up, the conical striations are replaced basically with just straight ones. So these are basically just straight up and down. There's no cone at all. This scales in centimeters. So these are some of the ones that we picked up. That one's got a nice vein running through it and some lichens as well. So the host rock is quartzite. This one's got kind of a pinkish appearance. Kind of a tan appearance with more kind of gentle lines. Kind of an orangey coloration. Kind of coarse striations with some lichen attached as well. This is probably the closest to an actual conical shape, but the specimen itself is kind of shaped like a cone, so the striations are still pretty straight. I've got two samples of the shadow cones. I think I'll just put them on the table here. So feel free in the break to take your flashlight and just move it around the shadow cones, and at a couple of points it'll actually catch the striations. So for more info, check out Chaco Dale's website at craterexplorer.ca. Great, thank you very much.
Any questions for Mark? One,
Yes.
Alice.
Yeah, are there any places in Alberta with shatter cones that are visible?
Yeah, the one in particular is the Eagle Butte impact structure just on the northwest edge of the Cypress Hills. It's a pretty old structure, 65 million years ago, but there's obviously some exposed bedrock of that age. Peter Brown and I were looking for meteorites back in 1990, and we made a side trip. And sure enough, there was one single boulder kind of on a hillside with a beautiful conical shadow cone right on top of it. So yeah, you'd have to ask the landowners around there, but there are some exposed areas where you can find shadow cones at Eagle Butte. Yeah, very interesting. Any others?
Okay. Well, thank you very much.
Great, thank you.
We'll see you later for buckle 'em up. Okay, so we're going to get Orla set up here in a couple of minutes here, and he'll be providing some musical interlude.
Yeah, my name's Orla, and I'll do something a little bit different dealing with astronomy. So after my retirement in 2000, COVID started, and I decided to put some of my songs on a PowerPoint and play. And this, I'm going to trust Frank, if I get out of sequence, the slide should feed itself. I got a timer on it, but if it gets out of sync, and just maybe press the forward, backward button. And so I've written a number of astronomy songs over the years, and I've got PowerPoints, and I've picked a couple here. We'll see how much time I have. Okay, so enough for 3 songs if I'm lucky, and I don't talk too much. So this is about a star party, and I think everybody knows what star parties are here. We're having one coming up in September at Black Knocket Lake, the, what's it called again?
Northern Prairie Star.
Northern Party Star Party. So this could be our theme song where everybody kind of gets together and plays this song during the night. So this is my kind of imagination what a star party would be like. So Frank, if you could just feed the first slide and then I'll start playing. There we go. The sun is going down and the stars are shining through. There is not a cloud in sight and the moon is almost blue. This could be a perfect night, oh, the atmosphere is still. There are no northern lights on top of this hill. So it is time to start the music. The time has come to dance the night away. It's time to look up at heaven. There is nothing that compares to the Milky Way at night, when the sky is a velvet black far from the city lights. When the moon is nearly new, the stars will guide your way. Oh, what a perfect start to the ending of a day. So it is time to start the music. The time has come to dance the night away. It's time to look up at heaven. While the sky is slowly turning round the northern star, we begin to contemplate where we really are. And in the stillness of the night, you can clearly hear sighs of wonder. Music to my ear. Oops, music to my ear. So it is time to start the music. The time has come to dance the night away. It's time to look up at heaven. We look at distant galaxies and nebulae and things. We look at comets drifting by and stars that blow smoke rings. We reminisce about the times we saw the other night. We talk about what we will see before the morning light. So it is time to start the music. The time has come to dance the night away. It's time to look up at heaven. Much too soon the sun comes up and the stars begin to fade. We say good morning to the night and to the friends we made. Tomorrow is another night, oh, I hope the sky is clear. Unless it's pouring down, you know I will be here. And once again we'll start the music. Once again we'll dance the night away. And we will look up at heaven. Thank you. A few minor glitches there. I was trying to look up at the slide, but my hat gets in the way. So that's one version of a star party. So I got another one that I wrote, I forget, back in maybe 1990. I was at a star party held by the Winnipeg Centre out at a place called Birds Hill Park. And so I called it Birds Hill Park. And the subtitle is Dance the Night Away. So it's a little bit more sedated. Okay, let's go. Oh, I gotta start my slides too. Darn. Standing in the darkness by the roadside in some park outside the city, looking up at the sky, with people asking questions to which they don't want an answer, 'cause they've heard it on some TV show now. They just want a dancer to dance the night away. You were another dark cloud within my field of vision, blocking out more distant starlight, so I knew of your existence. A dusty cloud of molecules with temperatures near zero. I could only see your outline with your hair reflecting starshine on a night in Birds Hill Park. Then you took me by surprise. You were warmer than I realized, and I looked beneath your dark disguise. Stars are burning in your eyes. Stars are burning in your eyes. was turbulence with particle accretions. Contractions were releasing heat which was increasing. You were calmer on the outside, but not really. I saw markings. Smoke clouds were turning from some deeper yearning to dance the night away. Down further there was fusion, far below the dark confusion. Down where starlight pushed outwards, trying to lessen the illusion. And their gas jets were forming, flowing out in both directions, trying to overcome the darkness by creating more reflections on a night in Bird Hill Park. So you took me by surprise. You were warmer than I realized. But when I looked beneath your dark disguise, stars were burning in your eyes. Oh, you took me by surprise. You were warmer than I realized. When I looked beneath your dark disguise, stars were burning in your eyes. Stars were burning in your eyes. Stars were burning in your eyes. Standing in the darkness by the roadside in some park outside the city, looking up at the sky, with people asking questions to which they don't want an answer, 'cause they've heard it on some TV show now. They just want a dancer, so we danced the night away. We danced the night away. Come dance the night away. Thank you. How are we doing for time? How are we doing for time? That's enough. 2 songs is enough.
You got one more?
Well, I got lots more. But I didn't bring
Time
them.
for one.
So I'm going to try this one here. It's called Mad Astronomer Pirate. So it was a song. It was written by the RASC Edmonton Council in 2007 as a part of an April Fool's General Meeting. And the melody is taken from the Last Saskatchewan Pirate by the Arrogant Worms. So maybe some of you here were part of that meeting. I don't know. It's a while ago. Anyways, it was lyrics were put together. I think Krista Stefan was the main instigator for this. But I've got the words here, and within the song there's some pirate sounds which you can participate in by saying things like "arg" during the pause. There's a bit of a pause, so don't hesitate. Just saying "arg" if you have a good pirate sound. All right, let's start. Here we are. I was an astronomer, I tried to do it right. I had a nice observing site far from the city. Sorry, gotta scroll. City lights. But time went by and though I tried, the dark sky wasn't there. Developers came and built next door and told me they don't care. I went through every agency, the answer always no. Dark skies now, they would laugh, we love this orange glow. The government said that they would look into the problem soon, but promises don't bring dark skies during the new moon. Then I thought I'd give a damn that the stars were gone. I'm going to be a pirate in the city of Edmonton. Arrgh. So, yeah. And it's a heave-ho, hi-ho, coming down the lanes, breaking balls and street lamps, extinguishing the flames. And it's a hey-ho, hi-ho, escort in your lights when you see the mad astronomer on the city streets at night. Well, you think the auto dealers would know that I'm at large, but just the other day I found an overlighted Dodge. I snuck up on the car lot, they didn't see me come. I smashed their lights and put them out and called, "So long, scum." A bridge outside of Blackfoot spans a mighty river. Drivers cross in so much fear, their stomachs are a quiver. 'Cause they know that mighty Bruce is hiding in the bush. He'll jump the bridge and smash their lights and kick them in the tush. And it's a heave-ho, hi-ho, coming down the lanes, breaking balls and street lamps, extinguishing the flames. And it's a hey-ho, hi-ho, escort in your lights when you see the mad astronomer on the city seats at night. Well, Ranger Bob, he chased me, he's always such a dope. He'd hide behind the tree line, 'cause he didn't own a scope. But changes were coming, the Ranger came to see that dark skies were terrific, he declared the DSP. Swinging Dobson, Cassegrains, and pleasant company, I never pay my power bill, and screw the MDT. Screw it, yeah. From St. Albert down to Bonnie Doon, you really have no hope. If you want to hear if you want to reach the Tuesday deck, boy, well, you better bring a scope. And it's a heave-ho, hi-ho, coming down the lanes, breaking balls and street lamps, extinguishing the flames. And it's a hey-ho, hi-ho, ever dim your lights when you see the mad astronomer on the city streets at night. Well, dark skies are appealing, but you just don't find them here. I hear that down in Calgary there's a band of buccaneers. They roam the bow from Cochrane down to Fish Creek Park, and they're gonna lose your white light if you pass them in the dark. Well, summer is a-comin' and the days are getting long. My pirate days are over once the twilight lingers on. I'll be back this autumn, but now I have to go. I hear there's lots of dark skies down in New Mexico. And it's a heave-ho, hi-ho, coming down the lanes, breaking balls and street lamps, extinguishing the flames. And it's a hey-ho, hi-ho, escort dim your lights when you see the mad astronomer on the city streets at night. And it's a heave-ho, hi-ho, come down the lanes, breaking balls and street lamps, extinguishing the flames. And it's a ho, hey, hi, hey, escort dim your lights when you see the mad astronomer on the city streets at night. When you see the mad astronomers on the city streets at night. When you see the mad astronomers on the city streets at night. Excellent. Thank you.
Thank you, Orla. That was an apropos song to end it. Thank you very much. Okay, now we'll get back to the agenda. Group, Murray Hunt, you are next.
Oh, thank you, Arlie. That was incredible. I won't even try to follow that up. Yeah. I would like to welcome everybody, though, to the Twilight Zone. Yeah.
The sun doesn't go more than 18 degrees below the horizon from now till 1st of August. Doesn't mean we can't do any observing, especially if those lights go out. Stars, double stars, the moon, double clusters, clusters. There's lots to see and observe, and aurora as well, as we've learned tonight. Okay, Alistair Ling and I are kind of leading the observers group just now. Visual observing. We have a monthly Zoom chat, what we've seen recently in different topics. Watched what for this coming month? Okay, skip April 21st. In person, in town get-togethers, and dark sky trips close to the full moon. Okay, I was looking at the RASC calendar and I saw April 26th. It's supposed to be a good time to see the lunar straight wall, Rufus Recta. And so 6 of us got together overlooking the university farm. It's a nice warm evening, got together at 9 o'clock to about 11:30. We were able to sit up in daylight, street lights behind us, no problem, because we were watching the moon. And all of us, 6 of us, were able to see the lunar straight wall. It's in the lower, southwest corner of the moon. And it's a linear fault line between these two, between Tebet and I don't know what the other crater's name is. And at certain times in the phases of the moon, a couple days after first quarter, and then 2 weeks later, it's visible as a long, straight, dark line. And about 110 kilometers long, and quite neat to see. So we were successful to see that. I got a story about this one. This I just took off from NASA site there. But that particular night, someone called out all of a sudden, "What's that teacup handle on the top of the moon?" And if you look up at that big sinus iridum, the northern wall, northwest wall, the terminator hasn't reached there yet. It's still in darkness, but because of the higher walls, it was brightly lit. Now, image doesn't show it very well. It was really bright, and in the black, it looked like it wasn't even part of the moon. It was an extra handle out of it. And so we talked about that, and I talked about sinus iridum and the bay and the wall and the sunlight and how it all worked. I was kind of excited about that. Came home and told my wife about this. And she said, "Well, why'd you tell him all that? Just tell him that that's the handle that Zeus used to hurl the moon up into the heavens." And I thought, wow, that's an instant myth. I really liked it. Now, this is a telescope built in the 1980s. It's the BAMT, Barry Arnold Memorial Telescope. It's an 18-inch reflector. And thanks to Barton Satchwell, it's been refurbished. The mirror is beautiful now. It's been recoated. And it's, as you see, it can be on wheels. And it's stored at Black Nugget Lake. Members who have authorized have taken the training course on it, how to get it in and out and how to operate it, are welcome to come to Black Nugget, at least during the county period or the society period, Thanksgiving to May 1st, and use this. Now, with it being refurbished, we may be renewed interest in more people wanting training on it. And those who would like to get training, you can reach me at my email address there. Limited spots are available. We're looking at doing trainings this summer, August 15th, 16th weekend. There's an operator training going on there, and we will have time at some point in there, probably the Sunday, to do some training. And also, perhaps, Northern Prairie Star Party, if more people are interested. It's about an hour demonstration, and then 1 hour per person to actually practically do it. Put out the ramps, open it up, bring it down, get it ready to use. And our next Zoom session, Tuesday, May 26th at 7 p.m. Luca Vanzella will talk about the facilities at Black Nugget Lake. There's more and more all the time. And then representatives of the Northern Prairie Star Party will come to speak on the event coming up in September. Registration will be open by then, and it would be a good time to start making plans for the fall. And then we'll go on any other observing-related questions, upcoming events, we'll talk about them. So that's Tuesday, May 26th at 7 p.m. Everybody's welcome. Thank you.
Thank you. Okay, so just before the break, we'll put up the trivia questions for the evening, and we'll take a look at those at the end of the night. Okay. What are the clouds of interstellar gas and dust that emit light in different colors called? What is the name of the first space tourist? And what is the nucleus of a comet made of? So we'll get back to those at the end of the evening. Can you go back, Frank, so we can bring up that RASC Edmonton apparel link? Jay Lavender will be over by the big white box there. If anybody's interested in a coat or a polo shirt, come and see Jay. He'll have some order forms. And I think he's also got the first batch to deliver tonight. So good. So that's it for now. And we'll take about a 5-minute break because we're running low on time here. And we'll get back to the announcements, book of the month, Astro Imaging, the answers, and final announcements. 5 minutes, please. Thank you. Okay. So let's thank Lori, Alan, Mark, and Orla for their presentation tonight. I think they did a great job. Okay, announcement. Okay, outreach opportunities. Please keep an eye on the Logistics VicNet site. See what's coming up over the next little while. Jeff Robertson mentioned that there will be an event coming up in September 19th, I believe, up in Lakeland area, Lac La Biche area. So that will be coming up shortly. And I believe there's going to be something in August around the 15th, 16th of the month with respect to the Perseid meteor shower that's going to be held as well. So keep an eye out for those items. Okay. Susan Brown would like to make a quick update on the NPSP, and then we'll get Ray Weens to give us his presentation.
Thanks, Clayton. This update is similar to what's in this month's Stardust, and it's also what's on our Northern Prairie Star Party website. So I'm just giving you hot off the press. As you know, Northern Prairie this year will run from Tuesday, September 8th, which is just after Labor Day, until Sunday the 13th, with most of our group activities planned for Friday the 11th and Saturday the 12th at Black Nugget Lake Park. Planning is well underway, and information that we have, general information on our speakers and program, t-shirts and the t-shirt design are all on our website now. Please register for all aspects of the party, and our online registration will open on Monday, May the 25th at 9 a.m. So check back on the website for the link to the registration page. All those planning to attend, whether you're coming out just during the day for Friday or Saturday, or you're camping for the whole 5 nights, all the registration goes through our online registration site now. This will assist us immensely with planning and help ensure that you get the campsite you want. because we have, as you know, limited power sites for camping, and those tend to go first. So they're in a first come, first served basis. And the sites that we've registered are sites 50 to 75 and group site 9. So that will all be live on Monday, May the 25th at 9 a.m. So I wanted to give you an update on our workshops and presentations. So Friday workshop, in response to feedback that we received from last year's attendees, many of them who attended Alan Dyer's presentation and workshop last year, we're organizing a workshop by members of RASC who use a variety of astronomy and photographic equipment to capture various types of celestial objects and employ different image processing techniques. So we're putting together a panel, and Tom Owen has graciously accepted our invitation to be the moderator for this panel, and it will run from 1 to 4 o'clock on Friday. So we'll have ample time for 4 or 5 people to present on their equipment for viewing, for photographing, capturing images, and for processing. So we're really looking forward to that, and more details will be available probably within the next month for the next Stardust update. At 4 o'clock, Clayton has agreed again to do the green laser certification, 1-hour session for the outreach volunteers who wish to take the course or renew their certification. It's be limited to 12 participants, so when you register, please let us know that you wish to be put on the list. And then we've rounded out our roster of 3 speakers for Saturday, September 12th. At 1:30, Dr. Brian Martin has accepted our invitation to speak, and he's going to be comparing the science portrayed in 3 great science fiction books with what the James Webb Space Telescope is currently revealing. So this should be really interesting. And the 3 great science books that he's going to be looking at are Fred Hoyle's 1957, The Black Cloud, and I hadn't had a chance to check to see if we have The Black Cloud in our library, but I hope we do. But it is available online. So that's The Black Cloud. And he's going to be looking at Carl Sagan's 1985 Contact and Andy Weir's Project Hail Mary 2021. So that should be a really interesting presentation. At 2:40, Dr. Yang Shen, who is a new assistant professor at the Department of Physics at the University of Alberta, is going to speak on auroras, their history, nature, physical drivers, and space weather impacts. I was telling Alan about this. He's a newly arrived professor and has been working with NASA in the States on various aspects of space weather. And at 4 o'clock, Jeff Robertson, longtime RASC Edmonton Center member and executive volunteer, will discuss the Artemis II mission, the historical background, the mission, and possible next steps. Rick Bram has designed a t-shirt that celebrates the successful Artemis II lunar flyby mission that took place this year. The t-shirt features a background comprised of the Orion constellation with the mythical Orion the Hunter holding the Orion spacecraft and the iconic Artemis II crew photo of the far side of the moon. You can check that out on the website or in the issue of Stardust. Check the website for updates. And for more information, or if you have questions, please talk to any of us on the NPSB planning team or email us at npstarfest@shaw.ca. And the other members are, besides myself, are Rick Bram and Alan and Marion Hobbs, who are present today, and Dave and Carol Mussel, who are not present tonight. Thank you.
Thanks, Susan. Okay. Next up, we have Gray Wings. He's going to be talking about the remote imaging opportunity. Backward, forward.
Fairly simple. Okay, thank you. So amateur astronomers in the Edmonton area are experiencing a number of challenges characteristic of central Alberta. And that is that we're dealing with, even when you go outside the city, Bordeaux 4 skies. And if you look at this last, 4 or 5 or 6 months, very little time for imaging. Sometimes it was really clear, but then it was -30 or -40. You can't go out. And now we're getting to the time of year where there isn't really astronomical darkness anymore. So that is some of the challenges. And if we look on the internet, we see that there are different opportunities in different parts of the world, the southern hemisphere, for telescopes, and where you can either buy data or buy time on a telescope and use that. So that opportunity is there. Okay, so talking with a friend about this and came up with the idea, what about if we could get together and as a whole group, those who are interested, and buy some time on a telescope somewhere, could we do it for cheaper? And so we came up with an idea, and we looked at Starfront Observatory in Texas. And this particular place is one of the fastest growing in the world. They have about 10 warehouses at this time. And you simply rent a pier there per month, so much per month, and you can install your mount, your telescope, your camera, your Immortal One skies, and you got 220 clear nights a year. So pretty fantastic from that point of view. And this just gives an idea of what they're doing out there. They've got the pier, you rent the pier, and they put the telescope on. You can send the telescope to them, and they'll set it up and everything for you. So thinking about that and wondering if there would be a number of members here who would be interested in doing that. And so we had the idea of putting forth a proposal to the executive where we would buy a telescope, the club would buy a telescope, a mount, and camera and so forth, and set it up there. And then the people interested would pay for the time on that telescope. So this is basically a survey to find out if there's people here interested in doing that. And if we get enough, then we'll put a proposal together for September to the executive and see where that goes. So survey is going to be on the web, and each one of you is going to get one by email. So here it is. I would like to be part of a group that shares monthly imaging costs using a club-owned telescope at Starfront Observatory in Texas. Yes or no? Number two, I'm somewhat interested in the project, but need more time or information. And that's pretty fair if you answer that one. I'm looking for more information too. So we need to get together, talk about it, and see if this is feasible. And what will it cost? Well, here's a proposal. If we would get 10 people here with the RASC who would say, yes, I would be willing to be part of it. The cost for a medium pier down there is $299 American. So you do a little bit of math, it works out to about $300 an individual for 6 months of imaging. And that would give you about 200 hours of imaging a year. Okay, so if you think about putting a telescope down there yourself, you would have thousands of hours a year where you could actually image, and most of us wouldn't need that. So here, if we could get 5-10 people together, it would cost not very much. And there could be projects where we share data with each other. If somebody says, oh, let's do 50 hours on this particular object, whatever it might be. So that's the very specific there. And number 4, a team would need to be formed quite promptly so decisions and work could take place before summer. Volunteers would be needed to determine equipment to be placed on a pier, what size telescope, etc., what kind of camera. There would have to be a primary person who would be responsible for the contact with Starfront Observatory, and there would have to be a system set up for managing time for those who would want to be part of that and who would sign up. And so if you'd like to be part of a team, then please do answer yes, and we would get together, hopefully I would think in about a week, and see if this is something that we would like to pursue. And if your answer was no, but you would be interested in a project that used a different type of telescope, or a project that rented time on a vendor scope, a project that imaged in a different part of the world, and you want to be part of a group that would explore these and other options, I'm probably not too interested in that. However, I would be happy to facilitate a group like that if there's a number of people here who would like to be part of that. Yeah, so there it is. Any questions or?
Okay, I do have one question. What happens if we get 20 or 30 people who are interested in that?
That is called a good problem. Well, I don't know. It would depend upon the club. But if you think about it, maybe there could be several telescopes with different focal lengths that could go in there. And we would ask the executive about that then.
Okay, anybody else have any quick questions? The survey will be put up on the website. And I will also be emailing a copy of the survey to all the members who are on our list that get the agenda every month. So it will be also on there, and hopefully we'll get that out by the weekend. Okay, thank you. Okay, we're back with Mark Zalcik to handle the book of the month.
Hello again. We have surplus books once again on the ledge. Feel free to have a look, and if you'd like to, there's a donation box. We have several of these books in the library, and what we're planning to do next month is to put them. We have quite a bit of empty ledge space here, I notice. We're going to put them out on all the ledges and call the event the Ledgerama. All the books we have out there, the surplus books, are hopefully going to be put out on the ledges next month, so something to look forward to. So, do we have the image for the book of the month this month? There we go. The library has over 700 books to be lent out by members. There's two ways of looking at this collection of books. You can come to the library before and after the meeting, just off the entrance to the Star Theater, and look at the books on the shelves. Or you can forego the idle conversation about berimbau music in the library and just go online. EdmontonRASC.com, click on library, and then click on the link, and you'll see all of the books right there, right in front of you. As far as the book of the month this month, who cares about particle physics? We have a selection of about 15 to 20 books in it's section L of the library, physics, chemistry, and astrophysics titles. And this is going to be the new addition to that. It's another one of the books donated by Renee Gadaz from Grand Prairie, who has donated a number of titles kind of along the same line, cosmology, physics, that sort of thing. So, who cares about particle physics? CERN, the European Laboratory for Particle Physics, regularly makes the news. What kind of research happens at this international laboratory, and how does it impact people's daily lives? Why is the discovery of the Higgs boson so important? Particle physics describes all matter found on Earth, in stars and all the galaxies, well, including our star. Apparently, neutrinos are emitted by our sun at a fairly good clip. Every second and on every square centimeter of the Earth, there's something like 66 billion neutrinos hitting the surface. In stars and all galaxies, but it tries to go beyond what is known to describe dark matter, a form of matter 5 times more prevalent than the known regular matter. How do we know this mysterious dark matter exists, and is there a chance it will be discovered soon? About 60 countries contributed to the construction of the gigantic Large Hadron Collider, LHC, at CERN and its immense detectors. Dive in to discover how international teams of researchers work together to push scientific knowledge forward. Here's a book written for every person who wishes to learn a little more about particle physics without requiring prior scientific knowledge. It starts from the basics to build a solid understanding of current research in particle physics. A good dose of curiosity is all one would need to discover a whole world that spans from the infinitesimally small and stretches to the infinitely large, and where imminent discoveries could mark the dawn of a huge revolution in the current conception of the material world. All right, book is available at the conclusion of the meeting. Thank you.
Thank you, Mark. Okay, for Astro Imaging Corner tonight, Ray Ween will be substituting for Tom Owen tonight. So,
Thank you. Oh, okay, is that it? And you can do it from the back there as well. So the first one is okay, Astro Imaging 155. Sorry, and the first image is it's called The Birthday Moon by Tom Owen. Tom captured this image on April 27th, his 72nd birthday. Congratulations, Tom. This image is a result of the best of 1,000 of 2,000 subs using a ZWO ASI 585 MC camera with a UV IR cut filter mounted on a Takahashi TSA 120 telescope with a TOA 130R reducer. Subs were stacked using Astro Stackert 3, and the image was processed using Star Tools. And the next one is by Murray Paulson, obviously Jupiter. I imaged Jupiter with my 6-inch refractor with a 2x Barlow. This image is time-stamped 404 UT on March the 15th, 10:04 p.m. Mountain Standard Time at the PI day. Okay. Camera was an ASII 290 MC stacked with 5,000 frames sorted and stacked with AutoStacker and finally sharpened with Regulus 6. And this is by Hans Jans, Heart of the Heart Nebula in RGB. The center of the Heart Nebula, IC 805, aka the Heart of the Heart. This one was taken with a dual narrowband filters, HA03 and S203. This one obtained without splitting into H, S, and O channels, but were just being added the RGB colors as they came out of the two filters. Taken from a Bortle 7 to 8 skies in Sherwood Park with a ZWO 12600 MC Pro camera. Image acquisition was controlled by Nina and image processed in PixInsight. Total exposure was about 16.5 hours with my 9.25 SCT focal length 1650 f4. That's pretty amazing, 16 hours here this winter. The next one, number 4 here. And this is taken by Tom Owen. This is a very rich image. It is NGC 225, an open cluster about 2,100 light years away in Cassiopeia. It is also known as a Saleable cluster. To the left of it is the Reflection Nebula VDB4, and to the left of the VDB4 is the Dark Nebula LND 1302. Other dark nebula abide in the image. And stars, lots of stars. The image is the product of 65-minute subs using a ZWO ASI 2600 MC camera attached to a Takahashi TSA 120 telescope and a TOA I-130R focal reducer for total exposure of 5 hours. Subs were stacked with DSS and processed using STAR tools, imaged at Pigeon Lake on August 31st, 2025. And the last one, oh, hang on. Something's missing here. I've got a page missing here. Oh, that's interesting. Well, this is taken by Hans Jans again, NGC 2841, the Tiger's Eye Galaxy, a tremendous amount of detail in that. And then we also have the moon taken by Alan Hobbs. And this is with a C-Star S50. I don't have all the details offhand, except I do remember one. It was taken exactly at 2 minutes to midnight. And that's 120 seconds to midnight, so he says. So that's interesting. Nice image, Alan. There we have it. Astro Imaging 155.
Thanks, Ray. I think you got my agenda there.
Sorry.
I like to have my paper copy. Okay, yeah, if we can get to the trivia answers quickly here, and we can finally get out of here. What are the clouds of interstellar gas and dust that emit light in different colors called? That's an emission nebulae. This was a tough one. What is the name of the first space tourist? Name of Dennis Tito. And the nucleus of a comet is made of ice, dust, and organic material. Okay, go to the final announcements. Go on to the cartoon of the month. Yeah. If I put that up in my backyard, not only would my wife be killing me, I think all my neighbors would too. Okay, go back, and the next meeting in June, which will be the last one until September, will be Monday, June the 8th at 7:30 p.m. And Sharon had got us a guest speaker for that. So we'll have a speaker that night and all the other things that we normally do. So thank you for everybody. And again, thanks to our presenters and Orla and Lori, Mark, and Alan. Thank you very much. Have a good evening.